Hello everyone, thank you guys for coming back to the channel. If you are new guys, please don't forget to press the subscribe button and the notification bell. We are still on the Free State June comment test written by matriculants who reside in Free State. This video will be focusing on trigonometry, so I'll just do question 3, 4 and 5. Let me see. Yeah, it's 3, 4 and 5, and then the last video will be on Euclidean geometry. Okay, we are given that sine beta is equal to 1 over 3, where beta is between 90 degrees and 270. Determine the following. Okay, here guys, it will be safer for us to draw the Cartesian plane first. Firstly, sine is equal to a positive number. We know that sine is positive on the first and second quadrant, right? And we are told that the angle beta is between 90 and 270. That means it's here and here. This process is called tick and draw, right? It simply means that our right angle triangle should be where we have the most number of ticks. The most number of ticks is on the second quadrant. Simply means that our right angle triangle should be on in the second quadrant, like this. We have our angle of beta there, and then we know that by definition sine is y over r, or opposite over hypotenuse. Simply means that this is 1 and this will be 3 together. And then for us to find x, just going to use the Pythagoras theorem. X squared and y squared is equal to r squared. We don't know x squared, but y is 1, and then r is 3. X squared is equal to 9 minus 1, which is 8. Then x is the square root of 8, which is 2 root 2, I believe. So we have 2 root 2. Okay. They want us to find tan B. Tan is always opposite over adjacent. So tan will be 1 over, let me just write it as root 8, guys. I think it will be easier. It will be easier for me. The square root of 8. So it will be 1 over the square root of 8, which will be equal to the square root of 8. And the square root of 8 can be further written as 2 root 2. No, whenever I rationalize this thing, guys, I'll have the square root of 8 over 8. And then the final answer will be root 2 over 4. Okay, and then now I want to calculate the cos of 2 beta. I can simply use what I'm given there, because I know that cos 2 beta is the same as 1 minus 2. Let me use a different color. This is 1 minus 2 sine squared beta, right? So it simply means I can say it's 1 minus 1 over 3 squared, which is 1 minus 1 over 9. And what will I get? I will get 8 over 9 as my final answer. So cos 2 beta is equal to this guy. Okay, whenever I have an angle which is greater than, less than 360, not less than 360 rather, but whenever I have negative angles, whenever I have negative angles, I need to add a 360 to those angles. When I say negative 450 minus plus 360, I'll get cos of beta minus 90. Are you together? And this thing is, whenever I see 90 plus or 90 minus, I need to change to the co-ratio. Are you together? But before I change, I need to check whether the thing that I'm changing is it positive or negative, right? Minus beta minus 90 is at the third quadrant. Are you together? And in the third quadrant, cos is negative. It simply means I'll have a negative sine beta, which will give me negative 1 over 3. Are you together, guys? Okay. Then now we have 3.2. 3.2 we are supposed to simplify, né? Excuse me. At the top, guys, we will have 4. Excuse me. The cos of negative x. Negative angles are at the fourth quadrant, right? And at the fourth quadrant, cos is positive. So we'll have cos x all together. And then we have cos 90 plus x. Whenever we see 90 plus, I need to change to the co-ratio. But before I do that, I need to check whether the cos 90 plus x is positive or negative, right? 90 plus is in the second quadrant and cos was negative there. Okay, now I know the sign, I can just change to the co-ratio. The co-function of cos will be sine. So I'll just write sine x all over. This thing is like an expanded version of the compound angle for sine. I have sine and cos, cos and sine. You can see that. And the first angles are the same, the second angles are the same. So I can simply express this as sine 30 minus x plus x. Whenever I expand this compound angle, I'll have something like this. Are you together? Okay, and then at the top I'll have a negative 4 sine x cos x. This thing is divided by a sine. The x's will cancel, right? We have negative x and positive x there. I'll have sine 30. Are you together? So this is the same as negative 4 all over 1 over 2. Whenever I'm dealing with fractions, I don't want a fraction within a fraction, right? So I'll multiply the top and bottom by the problem I want to remove, which is this guy, right? So when at the top I'll now have negative 8 sine x cos x. At the bottom I'll have 1. I'll have 1 like this, so I don't have to write the 1, right? This can be written as 4 multiplied by 2 like this. So I'll have negative 4, and this is the expanded version of the double angle for sine. So whenever you simplify this guy, you will get negative 4 sine 2 theta. So I'll simply say this is negative 4 sine 2x. Okay, we are told that cos 23 is equal to a, right? Simply means that whenever we use our right angle, if we have 23 there, together this will be a, this will be 1, and this will be 1 minus a squared. Are we together? Okay, they want us to find the tan of 203. Firstly, we must reduce the angle of 203. This is 180 degrees plus 23. We'll get a positive tan 23. Tan 23 is always opposite over adjacent, so it will be 1 minus root of 1 minus a squared over a. This will be the value of tan 23, right? And then for sine 46, sine 46 can be expressed as sine 2 multiplied by 23, which will be 2 sine 23 over cos multiplied by cos 23, which will give us 2. Sine is always opposite over hypotenuse. 1 minus a squared, and then cos 23 is a, so this thing is the same as 2a 1 minus a squared. So sine 46 is equal to that guy. Tan 23 is equal to that guy. Okay, now they want us to determine the values of the following without a use of a calculator. Okay, sine 105 can be written as sine 60 degrees plus 45 degrees, right? This is a compound angle. You can simply say sine 60 multiplied by cos 45 plus cos 60 and sine 45. Sine 60 is root 3 over 2. Cos 45 is root 2 over 2. Sine cos 60 is half. Then sine 45 is root 2 over 2. At the top I will have root 3 multiplied by root 2 all over 4 plus root 2 over 4. I can take out a common factor there. Let me just add the fractions. Root 3 times root 2 is root 6, and then here I'll have root 2. This will be my answer. So now I know that this guy will be equal to root 6 plus root 2 over 4. And then now I must find the value of cos 69 cos 9. Okay, it's cos 69 multiplied by cos 9 degrees plus cos 81 and cos 21 degrees. Okay, it's cos 69 and cos 9 plus cos 21 can be written as sine 69 according to the cofunctions, and cos 81 can be written as sine 9. It's together. this one is this one, and this one is that one then, yeah? So this is like the expanded version of the compound angle for cos. So it's simply 69 minus 9. Then we have cos of 60 degrees, which is equal to a half. So this guy here is equal to 1/2. Okay. Now I'm supposed to prove the identity then. The left hand side is sine 2x minus cos x, 1 minus cos. Okay, this is the left hand side, right? I must simplify it. Okay, there's only one double angle identity for sine, so let me just change it to 2 sine x cos x minus cos x all over 1 minus okay. Since I have a 1 in front, guys, I must change my double angle to the one that will eliminate this one. Are you together? Another hint I could have used, I would say I wanted to change everything at the denominator to have one trig ratio. Are you together? So I'll just say 1 minus 2 sine squared x. Are you together? And then I'll have 2 sine x cos x minus cos x is equal to 1 minus 1 plus 2 sine squared x minus sine x is equal to, there at the top I can take out a common factor. My common factor will be cos x. I'll be left with 2 sine x minus 1. At the bottom, these two will subtract one another. Are you together? So we'll be left with 2 sine squared x minus sine x. We can take out the common factor of sine x. We'll be left with 2 sine x minus 1. Then this will cancel this. We'll have on our left hand side, right? And then for our right hand side, we have for the right hand side we have 1 divided by tan x, which is 1 divided by sine x over cos x, 1 multiplied by cos x, which is equal to cos x over sine x, right? After simplifying the left hand side, you must go back and simplify the right hand side as well, and therefore conclude that the right hand side is equal to the left hand side, which is equal to cos x over sine x. All together. That's how you prove the identity. Please take a screenshot or pause the video and write everything down if you need to. Excuse me, guys, that I didn't remind you to do that previously. Okay, let me create room to write 3.6. I'm supposed to calculate the value of x if I'm given the restriction there. Okay, it will be simple because I can simply change everything into one trig ratio there. I can work with cos only, right? So that means this guy will be 2 cos squared x minus 1. Then I must put everything to in standard form. I have 2 cos squared x minus cos x minus 3 is equal to 0. This thing is factorizable, right? I'll have 2 cos x there. I'll have 3 and 1. 2, 3 minus and plus simply means that cos x is 3 over 2, which has no solution, or cos x is negative 1. Okay, our reference angle, will simply say cos of inverse 1. What do we get? We get 0 degrees. But our duty is to express the 0 degrees where cos is negative. So therefore I'll say x is equal to, cos is negative on the second and third quadrant. And in the second quadrant we write angle as 180 minus 0 plus k. On the third quadrant we do the same thing, 180 plus 0 is still 180. So we will still have the same solution, right? But since we are given the restriction, that means we must substitute the values of k that will give us the answer within that restriction altogether. Firstly, when k is 0, when we place a 0 whenever you see k, we'll get 180 degrees altogether. And then when k is equal to 1, we'll get 360 plus 180, which is a number that is greater than 360, so we'll ignore it. But when k is negative 360, we will get negative 180, and negative 180 is included. Okay, when k is negative 2, we'll get a number which is way less than 180, so that number will not be included. So the only answers that are there is 180 and negative 180. If guys you are given a restriction, your answer should not end here. You should go a step further to find the x values within the restriction, and we can only do that by just substituting the values of k. Okay, now let's go to question number 4. Okay, question number 4, we are given the graphs of f and g. Okay, and luckily they are drawn below. Okay, the graph intersects at point A and B. Okay, write down the value of the following. They want us to find the vertical distance at the y-axis of the two graphs. Okay, I know that for the graph of G, if I put 0 whenever I see x, because for the y-axis 0, x is always 0 on the y-axis, right? So whenever I put 0 there, I'll have negative half here altogether, and then there it's just 1. So my vertical distance will be 1 minus and negative half, which is equal to just 3 over 2. Okay, give the period of f of x if, or of f of x plus, okay, this thing simply means that whenever I see x I must put 4x, right? But remember that that means I'll have 4x all over 2, which is cos 2x, right? And then the period is 360 all over the coefficient of the angle. 360 over 2 will be 180 degrees. Write down the range. Okay. Please note that for g of x, g of x is the graph of sine. Sine of x minus 30 degrees. This graph is always between minus 1 and 1. All together, the graph is always between minus 1 and 1. But if I put a 4 in front here, basically multiply by 4, that means I must do so on the left hand side and the right hand side as well. If I multiply by 4, I must multiply by 4 here as well. So I'll have a negative 4 less or equal to, this is 4 times g of x. So the range will be between negative 4 and 4. We can simply write y is an element of negative 4 and 4. Given that the general solution of f and g is that determine the values of a and b. May I please erase everything here? Okay, the values of a and b okay, if I can substitute a 0 whenever I see k, I'll simply get 80 degrees. That means the x value there is 80. So the x value at b will be 80 degrees, né? So the x value at a, since a is in the negative side, whenever I put negative 1, okay, not negative 1, whenever I put 1 there, whenever I see k, I'll have 80 minus 240 all together, which will be negative 160. All together, whenever I put a 1, whenever I place a 1, whenever I see k, I'll get negative 160. So it simply means I'll have negative 160 here and then 80 here. Okay, for which values of x will the graph of f be above the graph of g? This is how you read that, you read that statement. The graph of f is above the graph of g. That thing only happens when x is between negative 160 and 80 degrees. Alright, together. For which values of x will be the products of the gradient of f and g be greater than 0 when x is positive? Okay, I will indicate that by using the for f of x, guys, I will use the red ink. They said I must focus when x is greater than 0, so simply means I'll focus on the right hand side of the y-axis. Okay, f prime of x just represents the gradient, or whether our graph is increasing or not. Are we together? If our graph is going down, it simply means our graph is decreasing, and when it's decreasing, it will have a negative gradient. Are we together? And then for g of x, whenever g of x, we're just focusing on y values, not the gradient. Are we together? Whenever g of x is below the x-axis, g of x would be negative. When it's above the x-axis, it will be positive. Why am I using the same color? Let me use blue. When g of x is below the x-axis, it will be negative. When it's above the x-axis, it will be positive. Let's get. They want the values of x whereby both the red ink and the blue ink are the same sign. Here, in this region here, my graph is decreasing, the graph of f is decreasing, and the graph of g is also negative. Are you together? If you multiply the two y values there, we will get a positive answer. Are you together? So I know that the x value there is 130, is 30 degrees rather, because my graph was shifted 30 units to the right. That means 30 was the starting point. So I have 30 degrees there, né? So I'll simply say when x is between 0 and 30. Guys, please go and check lesson number 20 on my YouTube channel. These things are explained. I explained properly, because that video just focuses on graph interpretations. Please go there, guys. Okay, now we are doing question 5. Okay. In the diagram below, a circle with center O passes through passes through A, B, and C. BC is equal to AC, and both of them are 15 units. BO and OC are joined. OB is 10 units. BOC is X. If OB is 10, that means OC is also 10 units, because OB and OC are radiuses of the circle. They want us to calculate the value of X. Okay, how can we find the value of X? Okay, you can just use the cos rule, right? You can just say BC squared is equal to OB squared plus OC squared minus 2OB times OC, the cos of angle O. Are you together? And then we know that this is 15 squared. We have 10 squared plus 10 squared minus 2 times 10 cos of x, right? 15 squared, I believe, is 225. Okay, let me confirm. Yeah, it's 225. this is 200 cos x, right? 25. Okay. Matla haya fedile lisada. Okay, when I divide by 200, there I'll get this, ne? And then I don't want to be fancy. X is equal to Zambaba 97.180. Okay. Now they want me to find the area of triangle ABC. Zambaba, hey. Okay, let me divide this thing by 2 equals to divide by 2, 48.59. Okay. Why am I dividing by 2, guys? I know that the angle at center is twice the angle at circumference together. Let me erase there just to create room to answer the second question. Zambaba yo. Okay. U. If x is 97.18, simply means this guy will be 48.59. Together, because the angle at center is twice the angle at circumference. Together. So if that's 48.59, this will be 48.59 as well. Together. So I can find the angle in between and then use the area rule to calculate the area of my triangle there. Together. Okay, let me erase. Mati work. So what's the angle? It's 48.59. So let me say 180 minus 2 times 82.82. Okay. According to the angles of a triangle, guys, this will be 82 point what? 0.82. I'm so sorry, guys, that I am doing this thing by a casual calculator. now I need to find the area of my triangle, né? I have the two I have the length of the two adjacent sides and the angle in between. Okay, so I'll simply say area of triangle ABC is equal to is 1/2 multiplied by BC and AC sine of the angle inside. So it's 1/2 82.82, and then what will I get? Let me go and punch my calculator. Okay, so it's 1/2 multiplied by 15 times 15 and the sine of 82.82. Was it 82.82? Let me confirm. Yes. What do I get? 44.65. So my area will be 44.65. How did I say degrees? Units squared. That would be the area of my triangle. Okay. Now I need to I'm given the figure. Okay, I'm told that in the figure below, K, A, and F lie in the same horizontal plane, and TA represents a vertical tower. TA is a vertical tower. Okay. ATK is angle X. KAF is 90 plus X. Okay, they're indicated. KFA is 2X, where X is between 0 and 30 degrees. Okay, we are told that X is an acute angle which is less than 30. TK is 2 units. Express AK in terms of X. Okay. We can express AK in terms of sine X, right? If you look at this triangle, this is a right angle triangle, right? And we have an angle there. The side opposite the angle is AK. This is the hypotenuse. Hypotenuse is always the side opposite the 90 degrees angle. So I'll simply say, since I have a right angle triangle, I can use my trig ratios, right? So I'll simply say sine X is equal to AK over 2. Simply means AK is 2 sine X. Are you together? This length is 2 sine X. Now they want us to determine the value of KF. What do we have? There we can use our sine rule. Ne? Sine rule is used whenever we have an opposite link. We have the angle opposite to KF, and then here we have both the angle and the side is known. Are we together? So I can simply say KF all over the sine of 90 plus X. Okay, before writing 90 plus X, let me just write all over sine A, right? And then AK all over sine KFA. Okay, that means for me to find KF, right, I must take AK, multiply it with sine of angle A all over the sine of angle KFA, right? The length of AK is this one, so I'll write it in green. Is 2 sine x, and then sine of angle A there, it's sine of 90 plus x. This thing is all divided by what? By sine 2x. May I continue on the other side, please and thank you. Okay, so therefore KF will be equal to 2 sine x. Here this thing can be written as cos x, because whenever I see 90 minus, I can just place cos x there, né? And then here I still have sine of 2x. Okay, 2 sine x cos x is the same as sine 2x all over sine 2x, né? Simply means that KF is 1 unit. Are we together? So KF is 1 unit. Okay, guys, I hope this was very fruitful. Please guys, stay tuned and wait for more videos. Thank you.